Okay, here's your review of Objective-C from the first 2 weeks because it's been a week since we've looked at this stuff, and so it's hard to start back in where I left off. So I'm going to quickly review, and this is it right here. So this is, believe it or not, what we haven't covered yet, and a review of what we have covered out of the first lecture. I believe I got about halfway through this lecture at one point. So we know object orientation is all about the object, and inside of the object we have 2 components. We have the data that's going to control the states of the object. And then we have the behaviors, which are the methods or the messages that are used to change the states and control what the object is doing. And all we do is we create a bunch of objects in a driver program or a main program. And after we create those instances of objects, then we have them communicate with each other. And then we communicate with it. Essentially, we've created a program using this methodology. And so we know we're breaking it out, obviously, into a .m and a .h file. Both of them are encompassing the concept of this class that we're creating, and the class turns into the object when we start making instances of it in the program. So the .h file is what's referred to as the interface, and inside of the file has an @ interface. And then we know in the .m file we have the implementation, so it starts out with @ implementation. We know we have an @end at the end, and we put everything inside of the @ implementation and the @ interface and at the end. Here's a little concept I don't know if I actually hit yet, so we'll hit it right now. The ID. We have this generic ID. We don't have this in other languages. It's similar to the pointer that we get in other, like C++ as an example, and we don't have pointers in Java, so we can't really equate it to that. But it's a generic object. So I mentioned before it's all about the object. What if we don't know what kind of object we want? We just want to create an object. And the object might be a time, it might be a date, it might be a person. And we want to be able to just create a reference to an object. Well, we have this special data type that exists in Objective-C. It's called ID. Actually, right here, ID. It's a data type used. It is a data type. It is used to represent a pointer to an object. So the pointer to the object is the object's data, and today I'm talking about memory. It's all about memory, which is why we can't compare 2 objects. If we have a reference to an object, what we basically have is a memory address. ID does nothing more than hold on to a memory address. And we say, well, what memory address do we want it to hold on to? Well, one for that object, or one for that object, or one for that object. What does that do? It makes it interchangeable. So we use this ID as a data type to say we're going to create an object, and it's going to be a pointer to this memory location, and we're not even going to put a label on it. We're not even going to call it a person or a date or a time or something. Which is kind of interesting because when we make 2 other references to objects, we're doing the same thing, but we're putting a label on it in terms of the type. So what does that do? Well, when we say, I want to make an NS string, and I go NS string space asterisk my string, which is how I would declare an NS string. The compiler knows that we're going to hold a string there, and what we did was, with that particular line of code, we made a reference to a piece of memory big enough to hold an NS string, which is the same concept you get in C++ and C, when you're using pointers. The concept being it's going to reserve and allocate that, and we've created a reference to that. We actually haven't created that yet. All we've done is created a memory reference to this location out there in memory that's going to store something. And in our case, if we said NS string space asterisk NS string, it's going to hold an NS string. Well, this is sort of doing the same thing, except it's generic. If we try to stuff something in an NS string space outside of a string, we might end up with not enough room, or we might end up with, I don't know, it's like some, odd reference. Why are we calling this a string when it's a number or something? Or, we might end up with some kind of an identity crisis when we start looking at the object. And we don't know what kind of object it is. We don't know how much memory we want. We can say ID. It's going to give us one that's big enough for all data types. So it's going to reserve more memory for us than we might not actually need. But it's going to make it so it's more flexible. And everything can be put into there, which is kind of the benefit that you get. So ID is a data type. It's actually a data type used that represents a pointer. It's a pointer object data. And it's sort of like the star in C++, but we also have the star, the asterisk, in Objective-C as well. Any type of object, as long as it's an object, can be used in the ID data type. So here's an example of how to create one. And we might actually see it today with the clock, actually. I can't remember if it's in there. If it's not, I could put one in there. We go ID space and object. And here's another interesting thing. When we do this, nil is reserved as a null object reference. And in other languages, when we have a pointer, most people are familiar with, sending the pointer to null, N-U-L-L, because we want to make sure it's not pointing to some memory that we're no longer using, which is really referred to as a dangling pointer. So to prevent dangling pointers, we make it equal to null. We don't have to worry about it. Well, we have the same kind of concept in Objective-C, but it's done for us automatically. So it's every time we create the reference to the object, this is already equal to nil. It means it's null. So they used the word NIL instead of NULL. Nil, null. People complain about my pronunciation of it, but I'm basically saying the same thing. It's null. It's null, meaning it's empty. Well, it's not really empty. It's null. And it's not zero. It's null. Which is another interesting thing. When we make instance references, object references to, let's say, for example, NS number, that's 0. No other language do we get automatic initialization to some value. So if we did that in C++, we said integer I as an example, and we said down on the bottom, cout I, and we didn't assign anything, we didn't initialize it, it's going to print out some weird memory that was there. But in Objective-C, it'll print out 0 because it's automatically initialized. So we have some automatic kind of memory management concepts going on with that. And when we create an instance here of a reference to an object, so we have ID and object, which is really a reference. We haven't assigned it to any new object yet. We haven't given it an object. We just said this is a reference to the object. It's automatically nil. So, which gives us dynamic typing. So let's go back and talk about typing. So unfortunately, it was 2 weeks ago when we talked about data types. Talked about strings and floats and stuff like that, and built-in object types. Hopefully you remember some of that. The ID has an ISA relationship because it's an object reference type. It's a generic one. So the ID data type has no information about the object. It's generic. But we have other objects that have information about their type. So every object carries what's called an ISA, instance variable, that identifies the object's class and what kind of object it is. And it goes through the hierarchy. So if you think about, I haven't given you too much on we're going to talk about inheritance next week actually. So not too much on inheritance yet, but if, for example, we had a person object, and from the person object we inherited 2 classes. We had inherited a student and an employee. And then maybe from student we had grad student and undergrad student. All of these guys within the same line, inheritance line, are holding an ISA relationship. As an example, a grad student is a student is a person. It's through the inheritance line, just the same way as an employee over on the right-hand side. And maybe we have president and we have technical support. Technical support object is an employee, which is also a person. But the technical support person may not necessarily be a grad student or an undergrad student. So they only hold the ISA relationship with the ISA objects that are inherited from the original object. And the original object is actually object. Everything comes from object. So I could make the employee equivalent to the undergrad by making them both objects. And if I created an ID, and this is why we use the ID, by the way, if I created a generic ID reference type and had it equal to an instance of a person, and an instance of an employee, and an instance of a grad student, they'd all be equal, like objects. So I could put them all in an array or something, or I could use them all together, send them to a method call or something, and use them as if they're all the same, and they would all actually be all of the same type. So we have to think about object reference types and how you're referring to the object. And what we can do, and I'll show you this next week, is we can cast up and down through the objects by treating all of the employees, the grad students, and the undergrad students all as people, all as person objects, and then use those person objects to, I don't know, to do something.
Is it similar to object in Java? Or is it the where?
Similar concept. It's the same concept actually in terms of casting from one object identity to another object identity. You can do it in Java, you can do it in C++. C++ it's referred to as a casting. In Objective-C it's more of a ISA You're not really casting it, because what you're doing is you're sending, in fact, in all of these languages, it's all at the same memory location. It's just, are you going to treat it like this object, or are you going to treat it like the object that's inside of it? And then, for the most part, what you're trying to do is build an inheritance, so you're overloading and overriding behaviors so that you're just complementing and you're supplementing with different behaviors, and you're improving or specializing that object as you go through it. And then all of it's available to you. So for compatibility among other objects, for comparisons, for equality, for all sorts of different things, we test the ISA relationship to see if they're compatible. Is it from the same line? And we know that it's of the same type, which means we can run a particular method on it, or we can do something with it, which is why we would need to do that. So in terms of dynamic typing, the ID here, the data type, has no information about the object. Every object carries an ISA relationship, or an instance variable that identifies the object. It doesn't really carry it. It's actually at the memory address. There's an imprinted stamp in the memory, and it says, you're a person, you're an employee, and you're also the CEO. Okay, good. So objects are thus dynamically typed. Some vocabulary for you at runtime. So whenever you need to, at runtime, you can find out exactly what the object, who the object belongs to, what inheritance, by just asking the object to tell me who you are. You can find out who you are. So everything is dynamically typed. Little refresher on messages, because I know some people are having problems with this one. And we haven't really looked at messages yet, but let's take a look at the message format. In other programming languages, we use a dot notation. C++, Java uses a dot. We actually have dot access, dot notation in Objective-C, but mostly we're sending messages to these objects. And the messages go in this particular format with the receiver message and then the message. And we saw this, I hope we saw this with a Hello World example where we took the name in and we changed the name on the label last week, or 2 weeks ago. So this is the refresher of your memory, where we use a dot set text, and with dot set text equal to something, well, we can do that, but it doesn't work in every instance. It only works with some methods that we run. And what we're doing is we're running on it on a non-object. We're running it on a static component that we put out there, like the label. We called the label, and we went the label dot set text, and we sent it a message. Well, that's really C++ kind of syntax, but it's, you know, written in Objective-C. But it's not a dynamic object. Well, it is a dynamic object, but it's treated a little bit differently than some traditional style object instantiations. And what you're going to be doing for the most part, that only works in a couple of instances. Especially, in fact, what you're doing is you're setting a property on the label. You're not running a method on the object. To run a method on the object, you could go the label space set text colon, and I showed you both methods, I believe, and you set the text to something, which is running a set text method on the label. So we know that it comes in this format, I hope, with the receiver of the message and then the message, which is why they call those methods messages instead of functions or methods. So Objective-C likes to call them messages because we're sending messages to objects. And then the receiver of the object over here receives the message and does something with it. And we have arguments that are passed through it. So here we have a couple of examples. So for example, this message tells my rectangle object to perform its display method, which causes the rectangle to display itself. So my rectangle, and then we have display. And then we have, this is also Java or C++ equivalent, my rectangle dot display, which is the equivalent to it. But in Objective-C, it looks like that. Such hopefully is a memory refresher, and this is not the first time you've seen it, hopefully. And then underneath it, we have these two parameters we're sending it. As I mentioned before, what that is equal to string with a colon here. We looked at that and said set origin, and we have two numbers that we're going to set to it. And we're using a colon instead of a comma to separate the two of them. And we know this is taking on two of them. And then the method set origin has two objects. So it has two colons, one for each one of the arguments that's going to be used. And we covered that. I talked a little bit about polymorphism, I believe, or did I talk about polymorphic behavior in objects? Probably not. Probably not. So each object has its own definition of its own methods, but for different classes, you can use the same method with different names and they have different meanings. As an example, if we go back up to this set origin. Man, that's not gonna really give us a good example. We have different types of methods that we can create in objects. One of them is called an initializer. And we haven't looked at initializers yet, I don't believe. In an initializer, when we create the instance of the object, we can send it some information. And if the object, as an example, had 3 pieces of information, let's say the object was a person, and we wanted to make a new person, and the person had a name, address, and telephone number, or something. We could make an initializer that just made an object with the name, or one that made one with the name and the address, or one that made it with all 3, name, address, and telephone number. That's an example of polymorphic behavior because we're making an instance, we're creating it with the information that we have, and it's going to set the other information that we don't have to different values. So the object is responding differently with different sets of parameters depending upon how we make the instance of it. We also have the ability to switch between the is-a relationship between objects as an example. So another form of polymorphism as an example, this is going for those people who have never had object orientation. I always mispronounce that word, so I always say polymorphic behavior. That polymorphism, I cannot say the phism part. Anyway, long story short, we can have an object that is a person. As an example, the employee is a person, and so is the grad students. We can morph them into people. Or we could take all the grad students and the undergrad students and turn them all into students, which means you're kind of changing your identity for your situation, meaning all students are allowed to take this course, and inside of this course we have grad students, we have undergrad students, we have outside students, and ITU students. That's kind of a form of polymorphism in terms of being able to change your is-a relationship back to something so that you're equal with another, or you're part of a grouping of another, which is kind of interesting. And we also have it through method invocation. As an example, if we had an object that was a shape as a base object, and we created a bunch of shapes, a rectangle, a triangle, and a circle, or a cone, or something, and we had an area method, through the inheritance and the implementation of overloading those methods, the area of a rectangle is going to come out with a different calculation than the area of a circle or the area of a cone or something. And when we call the area method, that's another form of polymorphism in terms of which method's going to be called. Well, what is it? And then it'll go through its inheritance all the way back to find the method that matches what it's supposed to be, and then it runs that method, and then we end up having this area that's all the same. It's the same method, but it does something differently. So in other languages like C or C++, as an example, we have C in and C out. Those are polymorphic object calls because are we taking in, or are we printing out a float, an integer, a string? We don't know. It's kind of like NSLog will print anything out. That's polymorphic behavior because we send it a parameter, say, hey, print this out, and it'll print out a string, it'll print out an integer, print out a float, double. Doesn't really matter what it is. So any ability to take in input of different forms, different shapes, sizes, different types, use it, understand it, be able to do something with it, or being able to output something, or to communicate with something of all different types, so various types. Oh, we ready?
Yeah.
Okay, I'll pause this one.
Apologies.
No, that's okay. All right, so don't remember where I was at, but I was talking about polymorphic behavior, and there's different forms of it. And if you bring it together with dynamic typing and ID, this is where all of the pieces come together in terms of being able to use code that can work in many different ways with many different types of objects. So the idea is not to have to reinvent the wheel every time you create a new object and you try to make new behavior. To apply any number of different kinds of objects without having to choose which one they are or what you're having to do with it, which is what that ID type is all about. And here's a picture of the inheritance that I've been talking about, and the fact that everything comes from NS object, as we see up here. And the inheritance is the accumulation of all of these objects. So here's a little picture that kind of shows you the big picture. And we're going to be doing this next week. So I'm not going to show you inheritance tonight, but instead next week we're going to take a look at this. But this is kind of the preview of what the direction that we're headed into. So right now we're just basically focusing on how to create objects. Once we get the objects down, then we can create other objects from it. And this is used in the iOS development as well as in the Mac development. So We'll see it today. Nope, we're not going to see it with any of the two examples we're going to start in with for today. But as an example, going back to that is a relationship concept I was telling you a few minutes ago, the NS object here has, in this inheritance, I usually put this upside down. I don't think of it going in this direction. I always put it on the bottom and work upward. So as I kind of demonstrate, and I use my hands a lot for this, I even did it for the person, and then I did students, and I did person. I'm always working from object down up. Most textbooks and most people actually look at it this way, opposite way around, so this might actually be more helpful to you. This is upside down to me, but I have NS object, then I have graphic, and then from graphic I have image, and I have this text concept, and also from graphic I have shape. So we have different levels in the hierarchy, and they go out in different branches. You don't have to branch out evenly among all of your objects, but what you want to try to do when you start building object-oriented programs is start thinking about the relationships amongst the objects and how one could be derived from another and how things fit together. And you want to keep the identities kind of intact. So they say when you take an object-oriented design course, there's 3 components of an object: identity, states, and behavior. And this is where the identity concept comes into place. You know, if I had a shape, another type of shape that came off of here, and as I like line, a rectangle, a circle, I see I didn't put square off of shape, I put square off of rectangle, which was kind of a design choice. So, you know, there's different ways of building the hierarchy and there's different motives, but what you want to try and do is reuse as much behavior as possible and then keep that relationship with the identity so it makes sense. So you don't have objects that morph into things that really don't make any sense. That's where science fiction comes into place, and people talk about morphing stuff, you know, a car that turns into a robot that turns into something else. It's the same concept in object orientation, and that can happen to you if you don't consider the identities of each one of these objects and what they really should be derived from. You can, you know, an airplane shouldn't turn into a boat in your program, theoretically, unless you want it to happen that way. And then we have the concept of instance variables and instance methods, class variables and class methods. So the instance variable is a variable or piece of data that belongs to each one of the instances that you're creating of your objects. And then the methods are belonging to the class instance, and you're running it on the instance of each object so that you can manipulate the data that belongs to each one of the objects, versus the class level, which is something that's going to affect all of the classes. So when we create the methods in your first assignment, actually, you'll have to create a couple of private, a couple of public ones. You probably could figure that out. But you'll have some instances and you'll have some class methods that you'll create. Let me show you an example of that in the next slide here. But what we're looking at are different notations in terms of the syntax, but also a really big significant change in the concept. So we run instance level functionality when we want to control those instances. When we want to keep track of all students, we might have a static or a piece of, well, Java would be static, but a piece of information. This is the same thing I went over last Saturday, or Saturday before. A piece of data that's held among all different instances of those objects. The same concept exists in Objective-C. It's referred to as a class member, or class data member, or class method. So methods are instance variables, contain not only the instance variables, but they also define inside the class, but also anything through the hierarchy of its superclass. So we accumulate variables as we go through the hierarchy. The methods is an object that has access not only to the methods, but also the superclasses methods as well. Those also get inherited. And then we have this concept of method overriding, which basically means creating a new definition of the method. And this would happen in the form of that example I was giving you before with shape. We'd have to override the method to calculate an area. We'd have to override it for a circle, override it for a square, override it for a cone, because it'd all be different calculations. So if we can override it, basically replaces the original if one was created. It could make it abstract and not create anything to override. But if we wanted to, we could override it, change it, customize it. Class objects. So compiler creates one class object to contain the information of the name of the class or the superclass. We only get one object and we have one reference to the object. If we want, we can create more references to the same object, which is how you get the ability to move objects around. Why would you want to do that? Well, if you're creating a dynamic list, you want to do, like, say, for example, if you're familiar with the concept of a linked list, you can easily create that by moving object references around to each one of the data components that are associated with each one. And then you can reorder the references and you reorder the list without actually having to move the data. Same concept applies with Objective-C. You start out by creating this syntax here. So now we're going to see ID being used. So this is referred to as an object reference. ID space my rectangle X. With a semicolon at the end. Should be really on its own separate line, but it's word wrapped in this slide. And then when we say my rectangle equals rectangle alloc, and then we have init next to it, we've allocated and then we have initialized this new instance. So we've actually created the object space in memory that is being referenced by this reference identifier, my rectangle X. So that's why we have the reference to the object and then we have the object itself, and the object itself is the memory location. So at any one moment of time we can say my rectangle, this is going to be equal to, we don't have to use an addressive operator, but it's really equal to the address of in memory this alloc that occurred. So the alloc is actually doing the allocation. The initializing is running what's called an initializer. So in some languages we have constructors. Actually, some languages we have a constructor, a deconstructor, a copy constructor. We have a bunch of constructors like C++. Other languages we just have a constructor. Objective-C, we have a constructor if we want it and an initializer. And we have to use the initializer. An initializer is just like a constructor. It's just called an initializer. And init is the initializer of super. And super is always the main object. Everything comes from NSObject. NSObject has a method in there called init. All init does is reserve memory space. Although alloc reserves the memory space, it just initializes it and puts a label on it. It says, hey, I'm an object. Okay, so we can use an initializer, and I'm going to go through constructors, maybe even as close as today, but we'll see how far we get. Probably not till next week as well. But those constructors, or the initializer, does nothing more than initialize starting points for memory. So, and not only that, but it says, so integer I was I equal 1. What is name? No name. Set some basic starting information. You can also pass information just like a constructor to the initializer. The way in Objective-C people use constructors versus initializers, and this is the weird part. You'd think that they would use a constructor, right? Like every other language. Instead, constructors call initializers. So you call a constructor the same way you would call it in any other language, and it runs the initializer for you, which is a different way of doing it. So long story short, if you don't like to write alloc, you don't want to say rectangle alloc initializer, then you create a constructor. Run it like you would in any other language. Inside of the constructor, you're running rectangle alloc in it. So we'll hit that next week with the examples. But just I try to give you what I'm going to give you and then give it to you and then show you what I've given you. So you hit it like multiple times. But we've seen this keyword alloc before. It returns the new instance and it performs the init method and sets all of the initial states, which is all it's doing. So, and what you end up doing in the beginning is you just get familiar with this alloc. This is alloc and init. And this is nested if this is word wrapped over, but this is really all one statement. So we know how to define a class, so I'm going to kind of skip through that a little bit here. We know how to do an interface. We know what this looks like. We'll see it in a few minutes. We know how to do declarations. We saw this last week. Last week we declared floats and integers and doubles. This part we didn't see. This is what we did with the methods. So if you remember before the methods that we defined, we put this minus sign in front of everything. We put the minus sign there so that we could mark it as an instance method. For the most part, you're going to see minus signs everywhere. And some new people, they try to pull this out because they think it's, a bullet point or something, or they think it's, what is that minus sign doing there? Because in other languages, you don't have that, and you don't have void in these opening and closing brackets either, which is kind of weird. And you just have, a data type. So the syntax is a little bit different. What this minus sign, though, is telling you is that it's an instance method. Probably not till another 2 weeks down the road, we'll make class methods. And when we do that, we're using a plus sign. So basically all we're doing is saying that this is a class method versus an instance method. And in that particular case, the plus sign is giving us that indicator. That's the only thing different. So in other languages, we might use a keyword static or something, or we might use different words. Objective-C is all about symbols. So the colons for the parameters, the plus sign, the minus sign. So the symbols are telling us what we're looking at. We also looked at this part as well, importing example here, importing the interface inside of the .m. We use a hash sign or number sign import instead of include. And as I mentioned before, you can also use include, but include is generally used for depreciated libraries or C++ libraries. You can include iostream.h. You can write C++ code in there. Xcode supports both. In fact, iOS development supports both as well, but you're not going to see that. You're going to see people writing, hopefully, Objective-C code in that. But it does work. And then we also see referring to other classes. This is where we have the @ symbol. And it's called an @ directive. So the @ directive is telling the compiler that this is another class, or that this is another string, or that this is something. So it's like a definition or a directive. So if the interface mentions classes not in the hierarchy, you can use it with a @ declarative here. So we can say @ class rectangle comma circle. So we can actually go through multiple hierarchies and include stuff that's not in the same hierarchy by using the @ symbol. And we'll see that in actually you see this a lot in iOS development, because you're going to include something somebody else did. It's a third-party framework. You're going to put it in there, use the @ directive to pull that class in, essentially. Alright, so we got the implementation, and so I'm going to kind of hold off on the rest of this because we actually kind of covered it. This is the rest of lecture number 1. It has a couple of different examples in it. I will come back here, however, in another week or so and look at more of the data structures components of it. So we're not quite done with lecture number 1, but we're pretty close. We're getting close to the end of the data structure stuff. All right. Oops, I'm like, why is that up? Okay. So let's see. Let's create a clock. I'll put some pieces together to kind of reiterate the point. And so the example I'm going to do right now is out on the website. It's not this one. It is. So now you're done listening to me. Well, let's do something a little interactive here. So if you have your computer, go ahead and get ready. If you go into the Object-Oriented Programming in Objective-C, and you click on the Source Code Examples section, so Source Code Examples of the Course Materials section, you want to download 2 examples right now. We're going to do the digital clock tutorial, and we are also going to use the using data types tutorial. I'm going to start with the digital clock one first because it's a little easier, I think, actually. So. And then some of you have already done the other ones, so maybe some of the pieces will come together. So if I open up my digital clock one, I can kind of see that I'm going to be using a property in synthesize, which was what I went over last time. So we're going to reinforce kind of the property synthesize thing. We're also reinforce using a timer and look at as well and kind of a review and get back into the mode of creating apps and methods and stuff. So we have some new methods that we're going to be creating as well. So I'm going to try and go through this slow enough so that people can follow along as I'm doing it. But go ahead and open up Xcode. And this is why for some people sitting here without computers, you want to get a MacBook computer. I see Windows computers here, which is kind of always funny in an Objective-C course to see people on Windows computers. You want to get, if you really want to learn this, you want to get a MacBook because you can't write Objective-C code on a Windows machine. So eventually you're going to have to, if you're going to write Objective-C code, you're going to need to get a MacBook. Okay. All right, open up a new Xcode project and go into create a new Xcode project. And we're going to create a single view application. If you're in the iOS course, we're doing different types of applications. But for this class, because people want to see Objective-C applied towards iOS, we're going to create an iOS application. So we're going to call it clock. And we're going to use auto reference counting and explain auto reference counting when I get done with this lecture. When I get done with this tutorial, actually, mix it up a little bit. Don't use the storyboard option, and you don't really need it for this application anyway. So, single view application. Make sure you have the iOS application up here selected. And then I'm going to call this one clock. And then I'm not going to use a storyboard, and I'm not going to include unit tests on the bottom. And I am going to use automatic reference counting because it's easier that way. And then I'm going to actually put my device on iPhone instead of creating universal. We know that if we do universal, we have one interface for the iPhone and interface for the iPad. So it makes it a little bit simple. I'm just going to create an iPhone application. And then click on Next. And then click on Create. And then we have the project that came up. For those of you who are interested and you have a Mac computer and you have a iOS device, I got your device ID, by the way, on your iPod Touch. So if you have an iPod Touch, an iPhone, iPad, you have an iOS device and you want to be able to run a project on it from Xcode, next week, bring your device with you. Stick around for 6:30. It's 6:30 for the iOS class. You guys can sit in on that one if you're not in the class. I'm just going to set it up once for both. So I'll be setting up your devices next week. So I got your device ID, but however, you know what ended up happening? I have to renew the account. My account expired. So we have a developer account with Apple for students, but I'm still in the process of renewing it actually. But it should hopefully be renewed within the next couple of days, and then when it's renewed I can start adding devices on, so I'll try and get you set up before next week. But long story short, you get 1 year free use of your device without having to pay $99. Without this student account, you have to pay $99 to get your device to work with Xcode, which is what they charge you for an account. However, with the free account that you get through the university, through the Apple Developer Program, Student Developer Program, you can't put anything into iTunes. So you can't put your apps for sale, but at least you can go through the motions and actually see the app work on your device, which is worthwhile. So, and because you guys are doing that, it might be helpful. Especially, it will last for 1 year after you leave here. So, but unfortunately, I didn't realize I have to renew it every year too. So my account expired. So it's a couple of pages of paperwork you have to put together. But next week, I'm going to run through that. So bring your computer and bring your devices next week. And I'll set everybody up as much as I can. Alright, so we're on step 2. Add a label to the viewcontroller.xib file. And then label it clock display. Alright, so just a little bit of review. We found the XIB file. It stands for Xcode Interface Builder. And down here on the bottom, in the object library, oops, I'm going to click on iOS, and what is wrong with my display? I'm on the wrong one. Let's go here. There we go. I have to click on the object here. Unfortunately, I've been doing cross-development for different stuff in here, so I have to change my defaults. But yours is probably on this one already. If not, I clicked on the third object over to get into the object library. And I had to switch it over to iOS, so if that was the case, maybe you didn't. But drag a label, stick it on the canvas, and I've got one right here. And it wants us to label it as clock display. And so we're going to add the following. Don't cut and paste this and put it in. Instead, let's wire it to the controls because we figured out how to do this. So we have some little extra practice here. So we can this is going to be our clock display, by the way. It's going to display a digital clock for us. So I'm going to make this one a little bit bigger, actually. And let's make this a really big. And I'm going to come over here and I have to get my properties back. Here we go. I have to click on the the fourth one over to get my properties back onto iOS, actually. And I'm going to change the text here to, I'll leave it on system, but I believe I'm going to bring it up to about, I don't know, 30, 35. I'm going to click on the background. I'm going to change the background color to something like this green color. Looks pretty good. And I can, if I want to, I can put like, clock display here if I want. And then I can see how big it's going to look. But we're working with data, and so if I wanted to, I can center it as an example. So I highly recommend actually coming through and playing around, because that's how you're going to get familiar with the tools that are here for the interface. So once we're happy with our clock display, it's just a label, actually. I'm going to click on this little tuxedo icon right here in the middle. I'm hovering my mouse around it right now to bring up my editor. And this is where I say we're going to create the properties. So as we mentioned before, we have property and synthesize. This is what we covered last time. Property creates, it's kind of like the initialization. It kind of says, integer I and a string. And this is where we'd put our other things as well. I'm in my interface. So it says interface here. And I believe my font's on this computer a little bit small. I can probably change my view settings. Or I can zoom in, actually. Zooming in works here. But this is where I'm dragging it to. So if I click on the label right there, and I press down the control button, and I drag it over, I should see that little blue arrow. And if I let go, I should call it display, or clock display. Remember what you call it, regardless of what it is, because we're going to refer to this particular object, and we're going to run a method on the object, obviously, to set the properties.
Why don't you bring up the view controller?
Okay, and I'm going to cancel this for a second here and do it again. I got to it over here on the editor. So if you click on the one that looks like a tuxedo, which is the second one in, if you do this, if you kind of come over here, and you do this guy over here gets replaced, which is not very intuitive. So the XIBO just comes up over here. Actually, whatever you click on here will always show up in this window. If you want something to show up in this window, you can select it up here, or you can select it up here by opening. If this window is gone completely, whoops, I'm hoping it was going to go away, but let's. Usually when you deselect it, it goes away, but mine's not doing that right now. You can turn on the display or turn off the display by clicking on it. And by default, the .h, did yours come up? Okay, good. So make sure that you're in the .h and not in the .m file, by the way. Alright, so I'm going to go ahead and press down the control button and drag it over, and then call this one clock display. This is a UI label. It's the data type for this particular object. It's a UI label object type. And it's an outlet. If you're in the Objective-C, if you're in the iOS class, I talked about the outlets last time, and the actions. But the outlet is basically like a input-output kind of component. We're going to leave this on weak because we want this garbage collected. The other option we have is called strong. Strong basically says don't garbage collect me. Weak says get rid of me if I'm no longer being used. So we leave it on weak. If we press enter here, or connect, you see the little button here? So for those guys who are here for the first day, if I want to know what I'm connected to, I just hover my mouse over the button and it highlights the window for me. So now it says clock display on it. And I'm going to kind of go through these first couple of ones on the slow side because I know some people have never seen this before. But what we just created, and I'm going to get rid of this side panel over here by clicking on this button right here. So now I just got rid of that side panel because I'm not going to use the clock display. I'm not going to use that window, that library over there. So for those of you who missed last week, take a look at the video, not last week, but the week before. We didn't have class last week, and we looked at properties and synthesize. When it says the same thing as saying, NS string something, or NS, actually in this case it's UI label. In fact, you see right here, this is the variable declaration right here. It's a UI label space asterisk clock display. We initialize this particular piece of data that we're going to hold on to. It happens to be of an object type UI label. Unfortunately, we have this IB outlet, and we have this other stuff here that confuses people. And this is what I kind of tried to go through last week. For every one of the properties over here, we do what's called a synthesize. So we could go and click on the .m file at this point, which is what I like to do at the beginning, because then I know I've got a set of properties and synthesizes. So if I'm going to call it clock display over here, I'm going to click on the .m file. And then up here at the top of the code, I'm going to see, and this is the confusing part again, you see another duplicate here. You see at interface and at end. But this isn't the interface file, this is the implementation. You can actually delete that. So it's just a duplicate for people who like to put it all into one file. But right underneath where it says at implementation, I'm going to put an asterisk in here. I'm going to go at synthesize. You see where it says here and it says property. What do you mean by that? Well, if I click return, I can start typing in clock display. And if I start typing in clock display, it's going to show me automatically. Hold up this little thing here. So I can just click on it or press return. And then I put a semicolon at the end of the line. So what this did for me as a review from last week was give me the ability to define a piece of data and initialize the piece of data and then automatically write what's called setters and getters. So instead of just saying, you know, UI label my label, and then I have to write my label or something, you know, get label, set label. So they're called setters and getters because what we're doing is these are private data members and we have to write public member functions to set and to get at the information. So this synthesizing property is the Objective-C way of automating the process. So it's kind of something different to get used to, but that's what that's about. And I covered that last time, so go back and look at the video. So we added the label to the viewcontroller.xib file and we labeled it clock display. I capitalized the C, doesn't really matter. I just need to remember what I called it. And now we have this line of code that's in my .h file, and I synthesized it in my .m file. And the synthesized part is not in this particular example because back when this example was written, it automatically synthesized for you. Which is what you're going to find if you look at old Xcode examples, old tutorials. They never tell you to synthesize anything, because that used to be done for you automatically. Not anymore. You have to synthesize it yourself. Why they took that out, I don't know. But old examples, including this one, doesn't put it in. So just remember, with every property comes a synthesize. Whether or not it's put in there automatically, you still have to do it yourself. So step number 3, in the viewcontroller.h file, we're also going to add another piece of data. And this one I can actually cut and paste. So I'm going to copy this here. So I selected it, I'm going to copy it. What are we going to do? We're going to create another object instance. And we're going to go back to, make sure you're in the .h file. So viewcontroller.h. And then I'm going to notice something interesting here. I'm going to notice there's some opening and closing brackets. And people aren't going to like this. Well, you're not going to like this if you're familiar with Java or C++, because when you create a class in Java or C++, everything goes in between opening and closing brackets. But when you create data in Objective-C, that's where the opening and closing brackets come into place. So in here I'm going to go paste, oops, you know what? I'm going to put this at the top of the code, underneath, cut. I'm going to put it right here, actually, where it belongs. Move that guy down. So you put in an opening and a closing bracket, and what I just created was another instance of an object called an NSTimer. So if I had, like, for example, integer I, this would go in here. Or if I had float F, this would go in here. Or if I had NSString, you don't have to do this, I'm just putting some stuff in here. My string. All my data that I'm going to create for the class goes in the particular opening and closing bracket that ends at the top of the, and think of this sort of like the class declaration. So this is the part people don't like. Underneath we put all the methods. So, which is the same thing for iOS, the same thing for Objective-C. In the class, the only thing that goes inside of the opening and closing brackets are the data. So if a lot of people want to go like this, just naturally, you're just going to want to put the methods inside of the opening and closing brackets, but don't do that. It's what you have, though, is the at interface and the at end. Make sure it's inside of those two. But the methods are self-contained units that don't belong inside of the data declaration. So I'm going to get rid of this stuff because really all we have is NS my ticker. Actually, I can just leave it there, but yeah, I'll get rid of it. Just clean it up a little bit. So we added another piece of information in here. We did it differently. We did it differently for two reasons. We're not going to have to get a getter and a setter for that. If I wanted to, I could put an at property, and I can define my own piece of data that's not linked to the UI. In fact, I can come down here and say, at property, oh, what am I going to call it? And I have to use the right syntax for it, and I can actually just kind of put it in, and then I can do it without any link. So don't think that it's just for the UI components. You can do it. I could have done it for this if I wanted to, but you're going to see I'm going to do something different with this. Okay, let's go back to the steps here. So we have the opening and closing bracket. Note that the ticker variable is going to be responsible for updating the clock label. So we're going to have an object that's going to update our clock label for us. So we're going to add the following new method declaration. So now we're going to put some methods in into the .h file, and they're going to be added in between the .interface and the .n. It is going to define two methods for us that we're going to write and to create the functional program. So I'm just going to copy this out of here. Step number 3, I'm copying it, and I'm going to stick it right in here. Still in the .h file, by the way. Let me zoom in so you can see what I'm doing. Underneath where it said at property, I'm going to paste them in. So now I have my two method prototypes, we call them prototypes, that I added in here that, again, aren't related. They're not related to IB outlets or actions or anything. They're just methods that I'm putting into the source code. So, just in case I forgot to tell you, make sure this is always at the top. It's always looking for the data. If you put it down lower, you'll get like a little red squiggly line. It wants the data initialized first, because technically you're going to be using the data throughout the entire program, so put it up there first. Alright, so we have a void run timer and a void show activity. Okay, so now we're going to go back and we're going to implement those two methods. And just to refresh your memories, or this minus sign means it's a method. Excuse me, it's an instance method. If I put a plus in here, that means it's a class method. And then we have the data type, which is void, it's not going to return anything. And the name of the method run timer and the name of the method show activity. Okay. So I'm going back to the tutorial. I'm going to switch over to the viewcontroller.m file, and I'm going to add the synthesize for the label property. Well, I just did that, so I did it out of order. That goes in between the at implementation at the at end. So make sure you have a synthesize in there. And then I'm going to add the method implementations that we just declared in the .h file. So I'm going to stick them in the .m file. So actually I'm going to cheat sheet that I'll talk about. I'm just going to cut and paste them in. So copy, and I'm pasting them, and I'll talk about them in a few minutes here. I'm pasting them into the .m file. I'm going to make this bigger so you can see what I'm doing. And where am I going to stick it? I'm going to stick it at the end. You can stick it at the beginning if you want. In fact, right now if I take a look to see, well, what is this error message over here? If I hover my mouse over this kind of an exclamation point here, I can see, oops, incomplete implementation. It means there's stuff in the .h that's not implemented in the .m. Well, that's these two methods I'm going to paste in here momentarily. So if you see this stuff here, that means it's just thinking for you, or thinking ahead for you. So if I paste them in here, that message should actually go away, and it does go away. So don't think of that as an error message. Think of that more like a hint or something. So I want to talk a little bit about the object start and the object lifecycle. And the program itself is running like an object. So what we have are these pre-built methods ahead of time. It says view did load and did receive memory warning. A lot of people are actually removing this because they're not doing their own automatic reference counting. We turned on automatic reference counting, so we're having the runtime environment manage our own memory for us. So that method doesn't really do anything for me. The did receive memory warning, I'm not going to get a more memory warning, I hope. Unless I'm allocating, deallocating, and I'm making a mistake. So a lot of people will remove it. I'm just going to leave it in. The view did load is kind of like the main, actually. You know, when your program starts up and you're writing a non-iOS, you're just writing an old C program, and you put main in there, Main's got the start of everything. Well, after the view loads, this is kind of why they call it, you know, they should have just called it main, but they didn't. There's a main. There's a real main, actually, for use for the same purpose. But in an iOS app, we don't have a main. Instead, we have a view did load. And this is going to basically trigger for us automatically when the view loads, which is, think of it sort of like main. So we put anything in here that we want to put in at the beginning. What's that going to be? Well, probably to start the timer, perhaps, or to do something with the timer. So we'll get back to that in a few minutes. But we're definitely going to have to put something in here to get this application started. So let me talk about the two methods here, and I'm going to fix that error in a few minutes. It's because I spelt it differently. So we have two methods, two method bodies that we put in, and remember the method bodies follow the same format as the method prototype, has the same signature to it. I still use the minus sign, I still use void as the data type, and this one's called run timer. But this is the implementation. So this one's going to start the timer when it fires the show activity, and it's going to fire the show activity. Show activity is right here, actually underneath it. You didn't really have to break it out, but we could, it's easier. I think it's easier to break it out into two. So what are we doing here? We're using this my ticker. And you're like wondering, where did my ticker come from? Well, it's from the .h file up here. This is my ticker. So my ticker is an instance of NSTimer, which is an object that we created. So my ticker, and then here's the method call. We're just running nothing more than a regular old method. And the method itself is on an NSTimer scheduled timer with time interval. And this is the parameters that we're sending it at 0.5 seconds. So the method, every 0.5 seconds is the interval that we're going to update the timer for. And then the target's going to be self. And then the selector is going to be at the selector. Well, what's the selector? It's going to be a show activity, user information. Well, we're not going to send in any user information, but we're going to repeat it. So we're going to say yes. Don't stress right now about this long convoluted method call. But one of the things you probably should probably notice is that we're running the method show activity inside of this method call, which is where we're getting this show activity from in here. So it's the method call is a show activity, and the at selector is selecting it, which is kind of interesting. Remember I said before the at directive is always telling the compiler something. So then the show activity method is taking an NSDate formatter, creating a new instance of this type of object, and we're going to call this object formatter. So we have the asterisk formatter. And that's going to be equal to, and then this should look a little bit more user-friendly too, because this is more of what you're used to seeing. NSDate formatter space alloc init, which means allocate this new instance of the NSDate formatter and then initialize it. And then here, then we have a second line of code underneath it here. In the second line of code, there should have been a line return there because it makes it more confusing to look at. We have a new instance of an object, and what's that going to be? NSDate is the type of the object, and the object instance is going to be an asterisk date, which means it's going to be called date, and we always use the asterisk for object pointers, equal to what is going to be NSDate date, which means run date on NSDate. Don't worry. All we're doing is taking built-in methods on built-in objects, creating new instances of a couple of objects. One of the objects is going to be a date, the other one's going to be the date formatter. So what we're going to do is we're just going to produce the time that looks like 12:50 hours, minutes, seconds, along with AM and PM. And we're doing that by running a method on it to formatter, time set, date format set, medium style. And you're probably wondering at this point, how do we know what all these methods are, and how do we get all these methods to work? This is where all of the reference books come in handy. So what you do is you go online and you say, well, how do we get the timer? What's the timer? And you figure out what the timer is. And what's the date? And then the time and the date are kind of related, actually, in this particular sense. They're not related, but they're used together in this particular case. And then however we set, what methods do we run? The NSDate is going to give us our date. It's going to give us today's date. This is how we're going to get the date and the time, actually, to show up. But we're not going to look at the date and time, we're just going to look at the time for this case, because we're going to set the time style from our formatter, and our formatter is our NSDate formatter. And that's coming from the show activity method. The show activity method's being called by my ticker. So my ticker is the ticker object that's going to keep track of the time. So it's that piece of data that we're going to, it's the object that's going to hold on to the other object's data that keeps changing as the time starts moving. And then set the label down here on the bottom. Well, this is a typo because I had a capital C, clock display, set text. And so now you can see what I was talking about before. I didn't go clock display dot label, or dot set text equals a string. Instead, I'm running the method. I'm running the method because I need to run another method. The other method, I've got two method calls nested into one here. The inner method call is run on the object. The receiver of the object is formatter. The method that we're going to run on it is string format date, given the date. The date is this date here from the NSDate date. So we have a date object that's representing the date. From the date, we're going to pull the time out of that, actually, because it's keeping track of date and time together. So clock display set text. Well, what's it going to be set to? Well, that's the formatter string from date date, and the string from date date is going to be, the formatter is set to set the time style from the NSDate formatter to medium style, which, how are you going to know that? You're going to go online and look it up. What are the styles? You got medium, long, short, different styles of the date format that are going to come out of this. And it's going to look like, that, essentially, when we print it out. So if I haven't lost you, let's go back to the tutorial. Number 6, we're going to put something in the viewDidLoad so that it starts automatically when the application starts loading. So to run it, the runtimer method only has one line of code to split into multiple lines. All of it does all of the same thing. So all it does is call the show activity method every 0.5 seconds. And then the show activity method formats the clock display method label, so it looks like, the hours, minutes, and seconds, and then sets it to the current time. So as mentioned above, it does it every 0.5 seconds. So we want to run the runtimer method after the view loads, and then the runtimer method is going to call the other one every 0.5 seconds. So the timer is what's basically controlling what's going on. It's controlling on the update. So it's kind of a primitive clock kind of implementation, but it works actually, which is nice. So it's a common method. The viewDidLoad is a very common method in Xcode generated by viewController.m, which includes a method called viewDidLoad, and the method is called immediately after the view loads, so after all of the items are loaded. So find the viewDidLoad, and we're going to paste in here actually I'm going to put this underneath the super, self runtimer. I'm going to talk about self in a few minutes, but we're going to add this line of code to the viewDidLoad method. Then we're going to compile and run it to see the clock working. So go back to viewController.m, and in this method here, let me show you something though. In the slide a few minutes ago, I had it on top. I'm actually going to put it underneath, because what I really want to do is have, I'm going to paste it right here, self runtimer. And I put this in the viewDidLoad method that's in viewController.h, which means after the view comes up, as I was mentioning, this is sort of like the main for viewController. What's it going to do? Well, it's going to run, this is the receiver, which is self, kind of like this, self. Runtimer is the method down here, runtimer. Runtimer is going to trigger every 5 seconds to go over and show activity. 5 seconds, show activity. 5 seconds, show activity. And so I put it underneath instead of putting it above because I want the super to load. Because remember I talked about inheritance, and super is the object above it. Self is this object, the current object. We can only go super and self, and every super can have a self to it as well. Depends upon where you're at. So if you're up in super, you say self, we're talking about the super object. In this particular case, it's NS object because we're not calling anything. So when we overload methods coming up soon, we will be running super on initializer, super init, to initialize the constructor or whatever method we want to do. Run this method too, run that method too, run that method too. So it's always a nice idea to put it above, because then you know you've built everything first, and then put your new stuff underneath it. So for this particular method, I want to run super viewDidLoad, which means an NS object. Run that viewDidLoad. Because what we've done here is overloaded it. We've overloaded the viewDidLoad method. Every object's got one. So we ran super viewDidLoad to initialize supers, and then we're going to run ours. So if I run it right now, oops, I should have a working clock actually. And you should have a working clock too if you've been cutting and pasting and following along.
What did you do to run?
Oh, I clicked on Run up here in the upper right left-hand corner of the screen. And I'm hoping that this little emulator, here it is right here, this little emulator is going to come out and show itself. Here it is. See, it said clock display, but then after the view loaded, then it changed over. And it is now 4:33, 28, 29, 30 seconds, which is what the format we wanted was. So now we actually have the clock working. So we can modify the behavior a little bit, make it into a stopwatch if we want, by adding more methods to start and stop the clock. Eventually, believe it or not, this will start sinking in. If you're completely lost at this point, hang in there for a few more minutes. And this will sink in. So I'm going to stop my simulator right now because I know my clock's working. Now I'm going to play around with the methods I already have. If you got lost right now, it's probably on the run timer and the show activity method. And because what I'm doing is taking for granted these method calls, schedule timer with format interval, which is just method calls. All we're doing is running pre-configured methods that were given to us for the objects. So what ends up happening is eventually you'll have to go, what is this NS timer? You go online, or you get one of those programming and Objective-C books, and you go, because there's NS timer, there's NS everything out there. And the only way you're going to memorize or even be familiar with any of these objects or any of the method calls is just kind of thumb through the reference material, and you go, ah. And then every version of Xcode changes. So you get, actually NS timer's been there from the beginning, so you'll get that for a while. But other stuff comes and goes. But alright, so let me go back to the tutorial, compile and run it. So now we're going to add 2 buttons to this here, make this work a little bit. Now you'll see the stuff that we're going to add right now is simpler, because we already have this taken for granted NS timer and how the NS timer works. All we did was create some method calls. That's what we did. Now let's make our own method calls. These are baby method calls, so these are a little bit easier, a little bit more straightforward. So add 2 buttons, a stop button and a start button, to your interface. And then we're going to wire them as IB outlets. We've done this once before in Hello World, but I believe this may only be our second program for this class. So some of you who aren't in the iOS class may not have had this yet. I'm going to click on this little guy over here, this on my view menu up here. I'm going to click him, and I'm going to hopefully see my side panel show up again because I took it away. And then on the bottom, I'm going to, oops, the second item, round rectangular. If I want to, I can type in button, and I can see all the different types of buttons that might exist here. But I'm going to just drag 2 buttons on here. And I'm going to get rid of this screen again because I don't like this. So I don't like it taking up my space. So on this button over here, I'm going to put start. We're creating a stopwatch. Start. And it's to demonstrate how to write methods and how to use methods and how to call methods. Stop. So now we have a start and a stop. And so I'm going to go to the right-hand side of the screen over here, and I'm going to make sure I'm on the .h file. So I'm clicking up here to the .h. I'm moving over, and if I come back to my handy cheat sheet over here, I can make sure I'm following the steps correctly. Add 2 buttons, and it wants me to wire the touchdown events. It doesn't really matter on the emulator. It doesn't really matter which events you wire, because they're all going to react the same way. It's a mouse click. There's no touching involved with this. Although, I will tell you, the most fascinating thing I've ever seen over the, not last week, yeah, it was last weekend, last Friday, I have a Yoga 13 Windows 8 with a touch screen on it. I loaded the Android emulators, and I loaded, I saw it happen with the Android emulators with a x86 Android system. The touch screen works. It was like the most fascinating thing in the world. I don't know why, because I'm so used to a computer, so used to a mouse, right? And then I was thinking about that when I saw this emulator come up. I'm like, I just want to touch the screen. But I can't do that with this because I can't install OS X on a x86 computer. I can, and this is an x86, but I can't put it on a non-Apple computer. And we don't have Apple computers yet with touch screens on them, but can you imagine what's going to happen when the touch screen, when we get the touch screens? You know how easy development is going to be now? Because personally, as a side note, if I were developing this application for mass distribution, I'd have to put it on a device, which is why all you guys want to test on a device. Because how am I going to test all the touch movements? The dragging, the touching, it works different with a mouse than it does with your fingers. So, alright, side tangent, but let's go back to here. So, now that I have you all relaxed again, we're in our .h file. Let's wire the components. How are we going to wire the components? Well, I'm going to stick them actually underneath. I'm going to put them underneath my properties and right before my methods. So I'm going to right mouse click on the little start button. And I'm going to hold down the control button and I'm going to drag click the touchdown event. And so I have that little arrow that shows up again. And I'm going to let go. And this one was called the start. So I'm going to call it start button. And then here we have that ID. What's the ID? You guys should know what ID is already. I gave you some boring PowerPoint stuff on ID before we started. ID is the generic object type. Well, but I'm really going to use it as UI button. So I'm actually going to change it to UI button. I could leave it on ID, no problem, and it would work just fine. It's generic. It's going to hold anything. But I don't know what it is. So now when I look at the code, I can see what it is. So I don't necessarily have to, but here's the other thing too. So let's say I'm writing an application that's going to use an UI button. And then I'm going to have another one that's going to be a UI something else, a label. And I want to interchange the label and the button. If I give the data type ID, I can interchange them. I can treat the button like a label, like a button. So if I click on a button, the label changes to the button text. So the ID makes it more flexible because I'm treating it like a generic data type. But I already know this data type here, so I'm going to put it on IB outlet. Excuse me, UI button. So touchdown. Why did I put this in here? I don't know, but this is the same options you get in this big black menu behind it. So I'm going to leave that one alone. Argument sender, sender, and event. This is the interesting part. So remember before, this is an event, the touchdown. So the sender is the event in this particular case. We can have an event that's not the sender. You're the sender. When you touch down, you're sending the event. We can have an event that occurs. Let's say, for example, this is an iPhone application and a new text message comes in. That's an event. So we can have this method trigger on events, or we can have it triggered on messages that are sent to it, like the touchdown, which would be an event that would send a message. So I'm going to leave it on sender. A lot of people do this because they want to make sure they can use it for both. Doesn't really matter. I just put it on sender. You can also put it on none and leave it so you're not going to, it's just going to be triggered. You know how this run timer and show activity was triggered? We can trigger our own action for our own button that's on there without actually sending it anything. So go ahead and press on connect. Do the same thing for the other button. So I'm going to right mouse click on the button, hold down the control button, control key, drag over, touch down, put it underneath it, let go. And this one's going to be called stop button. And I'm going to change it to UI button, touchdown, sender, all in the defaults actually. So here's a bit of inconsistent behavior that you're going to notice momentarily. When we put the IB actions here, we actually have the method bodies created for us in the .m file automatically. If I switch over to the .m file, on the bottom of my screen, which is totally inconsistent, I believe, I have the methods created for me down here automatically. So I don't have to do, that's why the synthesize and the property makes no sense. Why they took the synthesize out. They used to do them both for you automatically. Now you have to put it in yourself. So this is done for you automatically. So I have a start button and a stop button. What am I going to do? I'm going to send a message to the object. What object are we looking at? NS timer. Right. So if I look at the code here, We have we're gonna add something else to it. All right, we're gonna keep a counter. So we're gonna add a label and wire the property as counter time. Oh yeah, stopwatch. You know, we have to keep, you know, when we press start and then we press stop, it's going to count the number of seconds or something that goes by. Alright, so we're going to add, I forgot about the label. So we're going to add a label and we're going to call it counter time. So you get more practice with the labels. So go ahead and go out to the project. And I'm going to put the counter time right here, actually. And so I'm going to click back over here on my view to give me my panel back. And this is going to be a UI label. So I'm going to type in, I'm just going to type the word label down here. There we go. I'm going to drag a label over here. Actually, I'm going to put two labels on here. A label over here. Because I want to know what this is talking about. So in here I'm going to put here counter colon. And then this label here is going to hold a number. So I'm just going to put 0 in here. So I modified it a little bit. And I'm going to click this button over here to get rid of this view. So it cleans up my real estate a little bit. Because the start and the stop is going to keep track of some information for us. And here, I'll even move it over a little bit here. There we go. So I got two labels. Really, this is just for display purposes. This is really going to call my value, so I'm going to wire this one. So I'm going to make sure I go back to the .h file. Right underneath this first property, I'm going to put the second property. And what does it want me to call it? Counter time. Add a label and wire the property as counter time. Okay. So let's go back here. I'm going to make this a little bit bigger just in case my counter time gets big. I want to make sure it fits. So I'm pressing on it, and I'm pressing on the control button, and I'm going to put it right underneath this property. Letting go. I'm going to call it counter time. There we go. It's a UI label. Leave it on weak. It's an IV outlet. Just go ahead and press connect. Did we get this far? Okay, good. Stop me if I'm trying to go slow, but I have a tendency to speed up and go down slower again. So, all right. So now we have a new property. So we're going to have to add the synthesize. So we're going to click on the .m, and I'm going to come up here and I'm going to actually just put a comma right after clock display, synthesize clock display, and I'm going to call this one what was it called? Counter something? Counter time. Oh, here it is. I just start typing it and return. There you go. So we see that we shortcutted it, saved ourselves an extra line of code by just going clock display, comma, counter time. All right. So now you're going to have a working stopwatch actually at the end of this day, hopefully. All right, so we're back here. And so step number 8 was succeeded successfully. Step number 9, we're going to add some code here. So 9, we're going to add over here we're going to add more variables. So we're going to add an integer counter, and we're going to add another variable called, well, we already have NS timer, so we just have to put integer counter in here. So go back to the viewcontroller.h file. Viewcontroller.h. Right underneath where it says NS timer, my ticker, I'm just going to put in here an integer counter. Because when we turn it on, we're going to increment the counter. We're going to add some, so again, we're going to enforce the data concept. This is how you're using data, by the way, inside Objective-C data inside of an app. So this is why you're learning Objective-C, by the way, so that you can write stuff like this. Okay. Otherwise, you're just dragging and dropping and connecting stuff, and you're not really putting any logic in there. You can switch over to the viewcontroller.m and add the counter time to the existing synthesize. We did that. Actually, so if I were to rewrite this, I'd put this step right next to the property step. I always do so I don't forget. So we did that. We added it. If you haven't, add it right now. And then we're going to add the following code to viewcontroller.m to create the start and stop buttons. So I'm going to cut and paste here to the start. We'll talk about the start for a second here. back to this code here. In viewController.m, cut and paste and put in these two methods down here. One of them's the start, so I'm going to paste the start code in here. Let me talk about the start code for a few minutes here. Make this a little bit bigger. Zoom in here. And why do we have this huge space? Let's go this way. Alright, so we're setting here on the start button. We're going to start the timer. We're going to mess around with my timer. So my timer is going to be equal to, this is the object we're sending it to. It's an NS timer. We're going to run the method schedule timer with interval 1, which means it's going to count 1 second at a time. So we're going to keep track of seconds. The target is self. The selector is going to be the selector show timer activity. We're going to call that method again for the show timer. Wait a minute. Repeat. Yes, this is the show timer. Hold on 1 second. Let me just make sure. No, this is our start button. Our start button is doing the same thing as our show timer button is doing. So we don't necessarily have to show, we don't actually have to call the timer at the beginning. We're just going to start the timer. So this is an exact repeat of the code that starts the timer. But we're not, okay, actually we could call the method if we wanted to. Self, if we wanted to shortcut this in the code, instead of repeating this entire method body on run timer, we can just go self space run timer if we wanted to and run the timer for us, because that's what it's doing. And do we really need a start button? Probably not, because we're running the timer automatically for us. So we could pull out the stop.
You want to stop and start.
So we could take out of the view controller, we can go like this and get rid of this run timer. Because start is just nothing more than starting the timer for us again. It's doing the same thing as run timer, as I was mentioning before. So here we could, down here, instead of running the code again, we could just call the method by going self space, where is it? It's right here. Self space run timer, which is what we're doing up here in the view did load method, because we're running the timer. So it's a way of running a method that's inside of the object by referring to it as self. We still have to say self space run timer because we have to run this method, but the receiver of the method is us. We could run it on a different object, but we're just running it on the view controller object. Alright, so down here on the bottom, we could tweak that if we wanted to. But let's say, for example, we want to stop it. Well, then we're just going to run on the timer. We're just going to run a stop method. And that one's going to be kind of simpler here. It's going to be a my ticker, which is the name of the object, invalidate. And then set the my ticker to nil, which means it doesn't hold anything anymore. So I'm going to copy this, and I'm going to put this in the stop button. So we're invalidating it, meaning we're changing the reference type to an invalid status, which means it's no longer referenceable, if you want to think of it that way. So my ticker is the name of the object, and my ticker up here is what we're manipulating with the run timer, which is my ticker. So this is the my ticker up here, and then we're going to run a my ticker equals nil, which means basically making it an invalid reference now. We have stopped it completely. The object itself doesn't even have a reference anymore. Which is why on the start method we actually have to initialize it. So we're kind of doing this the long way. We're destroying the object, invalidating the object, and then recreating the object. Invalidate. But we're creating the object over and over again. We're keeping the reference, my ticker. So the reference to, which is actually kind of an interesting phenomenon that this is doing, the reference to the object has stayed the same. Once we have my ticker, we have my ticker. But the object that it's referring to keeps getting invalidated. Every time we hit the stop button, it's going to invalidate. It's going to be set to nil, which means this is unusable. If we tried to use the timer now, it's not going to work. But we're recreating it. Not the best design, but we're recreating it in the start button. and I say it's not the best design, is that we could actually stop this without destroying the object. But then I wouldn't be able to show you how to destroy an object and keeping a reference to an object that's already destroyed. And then how to use nail, because this is demonstrating the nail as well. Which is making it not a dangling pointer anymore. Alright, step number 12. We got this counter thing here, so we have to add the following additional method. And the additional method that we're going to add, it's a totally brand new method. It's going to be called show timer activity, which is run by another method that we just added. And the other method that we just added was show timer activity up here. So our start button, we can't really run self. So if you've changed it to self run timer, take it out. Because we're not running the timer, because we're not running the show activity, we're showing timer activity, which is a different method. So we're going to call two separate methods, which is why we want to repeat that code over again. So cut and paste this method and put it in, which is kind of interesting why I didn't get an error message actually when I put that in there. Show timer activity. And up here I have show activity. Show activity, this should be running show activity, it is. Okay. I'm going to stick it right underneath show activity. I'm going to put show timer activity right underneath it. And I'm going to say, well, what happened here? Let's take a look. Probably some extra spaces. My cutting and pasting wasn't the perfect job. And now I have some variables, integers, seconds. Let's see what this says here actually. Counter timer.text. Well, this is the problem here. I called it counter something. What did I call that memory? I called it counter timer, but I used a capital C instead of a lowercase c. So I'm going to change that text. And now that error message went away. So let's take a look at this method here. So in the new start button, we're actually calling show timer activity instead of show activity. Show activity, which is over here, and this one over here, show activity. So the selector is actually running a different method on that method call. And the method call here, this should hopefully look familiar to those people who have some programming background in some language. We have counter plus equals 1, increment the counter. There's many different ways of doing that one if you wanted to do it differently. Integer hours, minutes, and seconds. So we're keeping track of the hours, minutes, and the seconds. And what we're going to do is we're going to figure out how much time passed. And we're going to write it to a string and we're going to put it in the label. So we have seconds. And the seconds is what we're really going to add because we want to know how many seconds. So the counter minus the hours times 3,600 minus minutes times 60 to get that calculation out here. I can put a little line return in here if I wanted to because I have a semicolon at the end of that line, which means this is a new line. And the new line is going to be counter time dot text, which is what we're setting the property of. So going back to that, we're going to run a method call or we're going to set a property. This is really setting the property, it's setting the text property. It's not a space set text colon something, which is a different concept, but it's the same thing. It's accomplishing the same thing. And put a little space here, put that at the end. What are we setting it to? We're creating, from the NSString object, we're going to run a method, a message on it. So it says string with format, and here's our format. We're going to go 2 decimal places, colon, another 2, colon, another 2. And it's hours, minutes, and seconds. This is, if you're familiar with printf of C, actually it's string formatting that you're looking at. And what you're doing here basically is taking these hours, minutes, and seconds, which are integers, and you're formatting it out. So you have two precisions instead of a dot something or other. So we're going to get, if the hour is 1 and not 1 dot something, we're just going to get 1, or O1 essentially is what we're going to get out of that. And we're putting in here hours, minutes, and seconds. So this is actually the same format as a printf command if you're familiar with C. So if you're not familiar, at this point you've completely lost anyway. So when we're done, I'll show you this book by Deedle and Deedle. So I'm going to run it. I'm going to see what happens, actually. It's going to blow up. No, it says build successful. I left the timer running, so the clock display is going to run for me. I'm going to minimize this, though. Oops. Hello. So here's my running clock program. So I'm going to start the timer. And let's see. Let's stop the timer. And I'm going to say, oh, there's a problem with this. Well, I need to make it big enough because I'm going to show seconds. So I'm going to close this for a second. Go back to Xcode and make this little space bigger. Actually, I'll put it underneath. So I know it's going to be big enough. Oh, that's pretty big. This one should work. So I'm going to go ahead and start again. And hopefully show timer activity is updating on every single 5 seconds. So I have to, when I started, I have to, oops, wrong one. Back to the emulator here. When I started, I have to wait 5 seconds. There we go. 1, 2, 3, 4. What is it? I think it's every 5 seconds or milliseconds. So then if I stop it, this guy's still going, but this guy stopped. Because it's really two different instances of the same, well, it's the same type of object, but two different things running. This label is only being updated by the start and the stop functionality method. So this, we could easily update this one to update this label at the same time too. On the show activity, all we have to do is copy this. If we wanted this to continue updating this counter, because when we do start, it's going to pick up where we left off. So there's really two bugs here. The start could set this to 0, initialize this label to, well, initialize the counter to 0. And then the other functionality we can do is just if we wanted to, we just have an auto counter. And then this method here, which is going to be the show activity, can update the label at the same time as it updates this label. So it's really, you can update both labels simultaneously. You can change that yourself, actually. It's not too hard. So I'll give you a little hint on what you would do. So if you're inclined to upgrade your stopwatch a little bit, you could, on the show activity down here, make the counter equal to 0, or maybe make the counter equal to something. Maybe put a reset button here. Set the counter to 0, and then, or set the display as well. And then in the run timer up here, you can actually update from the show activity, which is showing activity on this label here. You can actually run another method called here to change the label of the counter to something. A little bit more trickier because then you have to actually figure out, well, what happens if the person does press the start button and it means they don't want this counter to work? Which means you have to make another method, I believe, to actually make that functional. So that's a programming challenge that you may take on yourself if you'd like. No obligation to, you don't have to. But it's one of the things you probably could do to make that a little bit better. Questions about the clock program? Alright, so the basic learning objective to this one was to see how the data was being used. Because last time, if you remember, we were talking about creating instances of objects and then using those objects in the program. And it also demonstrates the property and the synthesize, and also demonstrates the creating methods. And these are instance methods because of the minus signs here, and then the implementation of those methods that appears over here. Let's work with a little bit easier one. Actually, this is the harder one. The Fahrenheit and Celsius one is actually kind of easier. So, any questions on the clock? Oh, all right, moving right along. Let's start, and we probably could finish the Fahrenheit and Celsius one. This one's called Data. It's the second one you downloaded. Some of you did this already. So those people who are extremely burnt out at this point can just phase out and see if you did it right. And those people who want to follow along can. But this one is converting temperatures. So it's the same thing as we did before with the clock, but it's actually a little bit easier, maybe, I think. And we started with the harder one. So go ahead and close down your current application and then open up a new one. And we're going to create a new Xcode project this time. And it's going to be a single view just the same way as before. And this one we're going to call a converter. We'll call it converter. So go ahead and click on next. Converter. That sounds pretty good. I'm going to leave it on iPhone. I'm going to use Storyboards. I'm going to turn that off. And no unit testing. I'll turn that off too. I'm going to hit next. And I'm just going to create it on my desktop so I can get rid of it when I'm done with it. Because I create all these apps and I just get rid of it. So you create them and save them because you're going to want to refer back to them to see how something was done so that you can learn from it, unless you have to go through the tutorial all over again. But alright, so we did this part. Add 2 buttons, a text field and a label. Well, let's see, we got a label, text field, and 2 buttons. We're going to have a little bit more than that, but go ahead and create that. But what you're missing, what you can't see, is there's 2 more labels. Or actually, I think I'd take these labels and I add the Fahrenheit numbers to them. So same thing as we did before. Go ahead and put in 2 more labels for the output. So I'm just going to start adding the stuff. So 2 buttons, a text field, and a label. So we'll start at the top. What I'm going to do actually right now is change this full retina, full screen actually. I'm going to put it on the 3.5 because I like the shorter screen. The newer iPhones have a bigger screen, but I like the shorter screen for some reason. Doesn't matter. The emulator, well, the emulator is for either one. So. Alright, so I'm going to put a little label out here. What's that label say? Convert temperatures, okay. Convert temperatures. There we go. And I'm going to put a text field in here. So how am I going to know what that one's called? I'm just going to type in text down here. I'm going to drag a text field over and put it in here. And what else do we got? 2 buttons. I'll put the buttons over here. Round rectangular button here. And rectangular button here. Well, it looks like I got 2 more labels underneath it, so I'm going to put a couple more labels in there. This is kind of typical of the way that I build apps. You don't have to build an app this way. I like to build the GUI first. If you haven't noticed, I always start with the XIB file and I always build the GUI. And I always actually, believe it or not, stuff all the stuff on there and then I start labeling it afterwards. And then I adjust it all before I start wiring anything. Because I don't know what I'm going to take off, what I'm going to put on. So if I build and it looks okay to me, then I start wiring it after I'm done with it. Otherwise, what ends up happening is you get to have to clean the memory out. Because you'll wire something and delete the wire, and then it'll be labeled incorrectly, and then the memory gets messed up. And you have to clean the project out in order for it to work properly. Alright. Add 2 more labels for the output. These are hidden from the user initially. They show the converted output when the program is being used. The finished form should look something like this. I believe these are the 2 labels I put down here, Celsius and Fahrenheit. So I'm going to put a big old C on this one and a big old F on this one. I could leave these guys here alone, actually, and move them over here and add 2. In fact, I'll do that. Actually, let me just do that. Add 2 more labels on here. Because I'm not going to be able to tell which one is which. Because this program's got some logic problems too. And I always change my background color to green.
And how did you change the background?
Oh, click on the background. And then on the right hand side where it says background, over here. And then flip it to whatever you want. I like the color green. So yeah, it always looks better when you change the background color. Wire the elements to the .h file by control dragging them. So drag the 2 labels. Okay, so here's the other thing too. I like to work with the properties first. put all the labels on there together and then put all the buttons on there second. So the labels that I'm going to use plus the text property too. So label the two labels 2F and 2C. Where are the elements over there? So we're gonna do the 2F and the 2C labels down here. So I'm gonna click on the little editor over here, and I'm gonna click away this view over here, so I can make this a little bit bigger. You don't have to click on anything. Make sure you have the .h file showing, which I do. I'm gonna click and add this label here. In fact, actually, I'm just gonna bad UI design. I'm going to go here to C, and I'm going to go here to F. Just so I know that these things are here. Otherwise, I can't see them on the screen. So I'm just going to put them in there like that. I'm going to make it a little bit bigger so I don't run into that problem I did with the clock. Oops. There we go. A little bit bigger. Alright, so I'm going to click on the label, press down the control button, and wire it up here. This one's going to be called to C. Press connect. And this one's going to be called 2F. Control drag it over here, 2F. Push return. So now I got my two properties of my two labels, 2C and 2F. Those are my final results, by the way. So I'm going to put the final results after conversion over here. And now what do I have? Convert to C and convert to F, so I'm going to properly label these buttons here. Convert to C. And then this one over here is going to say convert to F on it. Alright. Hopefully you're doing something like this, getting your screen set up. So I'm going to take that text field that I have up there, I'm going to call it input. So I'm going to control, I haven't dragged the buttons yet, by the way, I just did the two labels. So then I'm going to control drag the text field over and I'm going to call it input. So I'm just going to control drag it though, because it's going to be a property, just like the labels were. So let me go back to Xcode. So this is the text box I'm talking about. So I'm control, drag it down here on the bottom, and this one I'm going to call input, because this is where the input's coming from. And I'm going to leave it on UI text field, which is what it is, weak, anything else. So now I have a UI label called 2C, a UI label called 2F, and a UI text field called input. I believe, do I have anything else over here? Let's see. Property, the property, the property. Now, on the outside of that, I just got the two buttons. And the two buttons I'm going to label next. So this is sort of like the way I like to organize it. It's kind of like putting all the data at the top and then all the member functions on below it, which is one way of doing it, one way of philosophy. There's many different ways of doing this. Alright, so next step is I'm going to control drag the touchdown events of the two buttons. And one is going to be called convert to C, or convert C. The other one's going to be called convert F. So it's going to be two IB actions, same as before. So I'm going to minimize this over here. Click on, right mouse click on the button. Take and press down the control button and drag the touchdown event right here. This one's going to be called convert C. Convert C. And the type is an ID. I'm going to change it to UI button. You can leave it on ID if you want. It doesn't really matter. Disconnect. And do the same thing for the other button. So I'm going to right mouse click on it to open up the little box here. Control, touchdown, event. And this one's going to be convert F. And then change the button type to UI button. Press connect. So now I have my two methods. Hopefully we got that. We have to synthesize, though, the 2C, the 2F, and the input. So I'm going to do that next, so I don't forget. So I'm going to click on the .m file. And then up here at the top, I'm going to get rid of this interface because I don't like it. I'm just going to take it out. You don't need the interface in there. especially for this project. And then right underneath where it says at implement, I'm going to write at synthesize. And I'm going to say well, here we go, we have it. We have a 2C, comma, 2F, well, let's put the input in here too, input, and then a semicolon at the end. So that line looks like this. It says synthesize 2C, comma, 2F, comma, input. If you haven't noticed, this is the same thing we did with the digital clock program. We have wired, essentially, some inputs, some output controls. For our case here was the only thing new really is the text field that we put in here. Alright, so I'm going to go back to my instructions and see where I'm at here. And so now I'm going to switch over to the .m file, and I added the synthesize. So I added the synthesize of the input, the 2C and the 2F. Now I'm going to add the following code to the following buttons, and I'm going to show it to you right here actually so we can sort of see, because I think this is actually showing up a little bit bigger than my code is on my screen. So let me talk about the code and then we'll just cut and paste it in. We're almost done with this program, by the way, because we just have to cut and paste and put this code in. And what's the code doing? Well, this code is a little bit easier than the timer code. That's why I say this project's a little easier, especially because we just went through the timer. And that one, it's kind of doing the same thing. So we have an NS string I highlighted here. NS string to Celsius is going to be equal to input text. Well, that's why we did the property and the synthesize on input. So we can get text. Instead of set text or get text, it's text. So when we say text, it's sort of like saying get text. But what we're doing is we're just pulling the text property from that object. So input as a label, excuse me, as a text field object has text. And that's going to be equal to the 2 Celsius variable that we created. And the 2 Celsius variable is a string. So we know at the very end when we write it out, we're going to need to convert the string somehow. And so what we're going to do in this particular case is we're going to say 2 Celsius. I'm kind of working inward and coming outward here. Calling a method that says give me the double value. So the method call says double value. It's kind of like doing a typecasting in Java. I believe you can put integer inside opening and closing brackets, and you say, hey, typecast this from a string to an integer. But we have to run the method this way because we're working with Objective-C. So double value of 2 Celsius. We'll take that, substitute it in, take this double value, minus 32 from it, times it by, what are we going to times it by 5.0 divided by 9.0. And we're going to have it equal to a double C, which is the temp variable we're going to use for Celsius. And then we're going to go 2c.text, which is kind of like a set text, but it's not. It's just changing the property of text. And that's going to equal to, and here we go again, we're going to create a string. We're going to create this string from C, and C is a double. So we're taking the double value and we're converting it back to a string so that we can put it on the label. Otherwise we're going to get garbage showing up because the label can only take text that's a string format. I will tell you about 60% of the time you're going to be doing this stuff. Because you're always going to want to put something out on the screen that's going to be text. It's never going to be text. So it's kind of nice to be familiar with some of the, to integers, to float. Here's init with format, init to allocate a string, and you're taking the string and you're having it equal to text, which is going to be the text for 2c.text. So the formula, it's just a regular old conversion formula. In fact, the program's got issues because how do you know what you typed it in with? Did you type in a float? Did you type in an integer? Did you type in a Celsius or did you type in a Fahrenheit? So you can easily move things around to change the logic for you if you wanted to. So I'm going to cut and paste this one here. And the convert to Celsius and the convert to Fahrenheit method bodies are doing the same thing. It's just going from one to the other. Assuming you have a Fahrenheit and you're going to a Celsius versus a Celsius going to a Fahrenheit. So I'm going to go back to my Xcode project here. And I'm just going to paste the code in here actually. And if my label was labeled something differently, I'm going to get a message, but no, I labeled it correctly. My 2C was actually my 2C method. Okay, good. So that one worked. And I'm going to simply paste in this code down here. I'm going to stick it in here. This is the convert to Fahrenheit code right here. And I'm going to get this functionality in here. So if I take a look here, nothing more than creating a temporary string to Fahrenheit, having it equal to the text, the input labels text property. So we're sending text, which is basically saying get text from input, but we don't have, because we use property and synthesize, we don't have to go set text, get text, we just say text, actually for both, and it works. And then the double F is going to be equal to, well, we'll just convert this text to a string, to a float format. Actually, I'm sorry. Initialize with format, we're changing it to a double. And then we're taking the double, and eventually we're going to set the text here. Actually, here it is here. So if we can have this one here and put a line return here, the code looks a little bit cleaner looking this way. So now if I run it, should work. Oops. I'm going to click on the run button up here in the left hand corner. And because this has some stuff on it, well, my UI is not going to look as clean as it could look. Oops, there's something for that one. Here it is. So if I put a value in here, oh, this is the other thing too. So I'll show you the keyboard, opening and closing of the keyboard next time. There's a way of getting the functionality to go away. There's a way of, this particular program is not going to auto hide this keyboard. So there's a way of getting, as an example, if I type in a number here, and then I type in a number here, it doesn't go away. There's a way of getting it so that when you're done with the input, when you press return, it goes away. You can actually use a keyboard on the emulator, by the way. Let's see, what is 70 degrees? 21 degrees, yeah, that's right. So if that's 21 degrees, Fahrenheit, 70 degrees. You can see though my C is supposed to be over here. It's not aligned correctly. But, and the functionality is working, equation works, it's just the, in terms of UI design, kind of sucky, actually. There is no button over here to get rid of the keyboard. But I'll show you that next time because I'm running low on time this time. But, and I have another project that takes and removes the keyboard and puts the keyboard back. So I can play around with the keyboard. What are you going to do? You just kind of call method call on the keyboard object and validate or invalidate it to get rid of it. But this is basic functionality that you're going to get. In fact, the select and everything works just automatically. Basic features. So now you have a working temperature conversion. So now if you wanted to, you can write a tip calculator. What's tip calculator going to do? Well, let me show you real quick. You can actually, design the GUI. Let me shut this down for a second. And say, I need a tip calculator because I can't figure out how much to tip. Well, I'll have this one, here we go. Enter bill amount. There we go. And put it over here. Obviously, the names of some of these labels are going to be a little bit off. Over here it says, well, how about a 20% tip? That sounds good. Well, how about a 30% tip? We really liked them. 30% tip. All right. Then we put these labels over here. Oh, do we need this one? Nah, we need this one? Probably not. Right. Then when they press the 20% tip, they're going to take this amount here, right? We already got it in, right? Didn't we get it in when we got it in from Fahrenheit, right? As a double. So down here it says convert F. We have a double C. Well, let's see. Celsius values. Well, double value. We don't need all this other stuff. We can just take double value, right? So we can just go like this with it. And it's going to be equal to Celsius double value. Well, double value. Yeah, there we go. Alright, we don't even have to do that. We can just go here times What's it going to be? 0.20 times 20%, 0.20 times it by 20%. So basically we're doing the same things, right? We're taking the double value of to Celsius, which is basically the input text. The text that we're typing in here, we're converting it. We're taking the text here, defining a new string that's going to contain the text that's going to be in this box right here. And then we're defining a double C, which is really supposed to be Celsius. But that one's going to be equal to this new string double value. So convert this new string to a double value times 0.20, and then this is the same. The 2C text is now going to be equal to the same thing. It's going to be equal to C. So let's see if this calculator actually works. So if I run it, given I got 0.20, 20%, no, that's 20%. It's going to tell me the tip amount. So I have to take the full amount and add it to the tip amount to know exactly how much I'm supposed to leave. If I really wanted to do it correctly, because I had $2.50. Okay, but then I have to add it to the bill amount, so I didn't put that in there. But if I just look at $20 and $4, is that right? 20%? Wow. So now I have to take it. That's supposed to be 24. So I can improve this. I can improve the functionality by taking it here and going, well, isn't this really going to be? Well, so we have that amount there times. Plus, okay, so we can put a little opening and closing bracket around this guy here. So that's the tip, right? Let's plus add it to. Oops. What are we going to add it to? Or we're going to add it to this here. The double value of 2 Celsius. We could call it something else. Copy. Okay, so now we got $24 coming out of that. Kind of small on my screen, so I'll make it a little bit bigger. I could have made a temp variable. That was a double value that did the double value from 2 Celsius. We kept using that over again, but I just call the method call over again. Like this, just add it to that. So now I should get $24. So if I run it now, and then here I can just go here. Really put a label. We're talking UI design. Let's just do it here. Alright, total is total. Here, pay this. Pay this. $24. You know what? I can even do this. Watch this. I can go like this. Put a little dollar sign in here. There we go. Move this so it's right up against that one right there. Yeah, maybe too close. Move it a little bit. All right, now I run it. It's going to give me $24. I actually need this app. I'm always constantly going. I used to double the tip. I used to double the tax, but that doesn't work anymore because tax has gone up. And I'm thinking, well, cost of living has gone up. Hasn't tips gone up too? I don't know. So now if I put it to $20 in here, now I pay $24. Pay those $24. So you can do, I can show you one even better, but not today because I don't have the device. If you have the device, you can actually, you know how you hit the those little hash things or whatever, you can actually hit the number and take the number in, and it'll tell you what to do automatically. It's just another API that's used, a framework actually that's used with the camera. Takes a picture, or you can actually, that's one way of doing it, taking a picture of the bill, of the number, but I think that's harder than just typing the number in, seriously. So I guess you could put in a sliding thing that says, what is the 20, 25, 30, multiple selects wheel? I can show you the wheel actually, put the wheel in there and multiple select the wheel and say, hey, it's $25, and just round it up. Well, so the tip should be this. Or something. So there's your tip calculator / temperature control program / I guess this could be a clock program too. It's a category of programs that sort of all fit the same design pattern. What is the design pattern? Taking labels and taking input boxes, performing calculations on them by using methods, taking those methods, the results of those methods, and populating the data back onto yet another label. So whether the label is showing you a tip, or whether it's showing you a temperature, or showing you something. It's basically input, output. So you can write probably about 100 applications that all do the same thing, all the same way. So what we're going to do next week is show you inheritance. So this is not using any inheritance. This is just creating basic objects. NSTimer is an object, NSString is an object. So what we do next week is we're going to create objects from other objects, and we can use them with built-in objects on the iPhone platform, or we can create our own object, inherit from our own objects. How are we going to do that? Well, we can create something, and I'm going to show you, hopefully if I remember, the audio video, where we create an mPlayer, and we can inherit from mPlayer, and we can not inherit, but we build on existing classes. We might not get to that. Inheritance is really a 2-lecture kind of thing. I'm going to start it next week. We're probably going to take the next week after that to finish it, is what I'm thinking. Questions? So now what you should do if you really want to learn this stuff is create yourself a tip calculator. Actually, you know, you probably could create a calculator. All you have to do is drag a lot more of these buttons on here. One button that has a big X on it, one button that has a big minus sign on it or something, and then make a one little thing here. You know, you type stuff in, takes the text you type in, and does this plus this plus this. In fact, you can parse the text out of there if you wanted to, really easily. Or you can keep track of it. Every time you click a button, it could store whatever you clicked. If I'm, for example, here, if I'm the number 1, I can set some variable in here to be 1. 1 is 1. And then depending upon what I clicked, example, if this one was 2, then I can go, 1 and put 1 up here, 2, change the text to 2, and then keep track of it as I'm putting it up here, keep a total, and then just hit sum equals, and then put that up here. And I've got a calculator. So it's all kind of done the same way, but the problem is trying to figure out, and every program is going to be a little unique, how to convert, and you're always going to always be converting the string to a number, taking the number, adding it to another number, doing some number calculation to it of some sort, and then converting it back to a string and then populating it out on the label, which is the basic kind of input-output. Okay, I think that's enough for today. I don't want to we're at 5:30 Are we supposed to go till 5:30? I think we decided we were going to go till 5:30. Is that how it worked? Okay. Where's the TA? Okay, good. You're doing the attendance stuff? Okay, so I'm going to stop this recording. Oh, for those of you who came in late, if you have a device, well, you have to have a computer first. In order for this to work, you're going to need a MacBook, and you're going to need a device. And what I'm going to do is set you up on a developer account so that it's a free developer account. So you don't have to. It's going to save you $99. What it'll allow you to do is actually run the app on your device, because some things on the device aren't on the emulator. Example, how are you going to take video pictures, record audio, which is some cool stuff you might want to play around with, which you can't do on an emulator. Plus also how are you going to control moving stuff around. We can click on it with your mouse and move it this way, but it's not the same as actually seeing it work. So next week I'm going to reserve some time during the class to hopefully set you guys up. I can't imagine everyone showing up, so I'll do it for a couple weeks straight, but I'm going to start it next week. So just keep that in mind. But you need a MacBook because you have to register through a keychain program. The information that's on the MacBook gets tied with your device ID, which gets tied to your student developer account, which gets tied to ITU, and it's good for 1 year. So if you want to pay $99, if you think you're going to put something in the Apple Store, you're going to need to get your own private account, because the one I'm going to give you for free is for educational purposes. You can't put anything in the store for that. So you can set the same thing up with your own personal account, but it's one account tied to one computer, tied to one device, which is kind of weird. So, and you need all 3 components together, and it's about a 20-minute ordeal to go through. So hopefully I'm going to go through everybody all at the same time is what I'm hoping to do. But it'll be an experiment. We'll see how it works. Otherwise, I'll see you next week.